All right, this has to be my favorite type of constraint. This is the generic spring constraint. So let me go ahead and show you this quick example that I set up, and then we'll set it up for ourselves. As you can see, we have 3 icospheres up here, similar to spheres, just a little bit different, lower poly. Then we have our actual spring pad and just a regular base floor. Let's go ahead and press play and watch what happens. Now, this one is a lot of fun to set up, and the settings are so much fun to experiment with, and you will need to experiment with them because the results are going to be drastically different depending on what you do. Let's just go ahead and play this back one more time. How cool is that? It's as if this pad right here is sitting on an invisible spring. So how do we actually set this up? Well, let's go ahead and delete everything. All right, let's go ahead and add some objects in. I'll start by adding in a cube. I'm just going to scale this down a little bit to create our pad floor. It can be whatever size you want. I'm going to go ahead and Shift D to duplicate that, scale it down, scale it up. This is going to be our actual springboard right here. Now we need 2 types of rigid bodies. You probably already guessed what those are going to be. We're going to go ahead and click on our base floor right here, add a rigid body type passive, and then this top one right here is going to be a rigid body type active. And that's really all we need. Now let's go ahead and add our constraint. Go ahead and click on your top cube here. I'm going to collapse this, add a rigid body constraint. Type is going to be generic spring. And then once you have that, we'll keep all these regular settings here. Now, there's 2 really important things to note here. There's our limits, and then there's our actual spring tab right here. Within our limits, well, I'll explain that in a second. Go ahead and open up your objects tab. Select your 2 objects, doesn't matter the order. I'll go ahead and select our top cube and then our second cube. You can see we have our relationship line, which means they're properly connected. I'll open up my limits tab. Now you see we have angular and linear. Angular is rotation, linear is up and down, sideways, X, Y, Z axes. Go ahead and drop down angular, and I'm going to checkbox all of these. I'm going to open up the linear tab. I'm also going to check all of these. For now, we're going to go ahead and keep those as is, and then I'll explain them a little bit. Open up your springs tab. Now, under angular, we're also going to check all of these too. I'm going to go ahead and set our stiffness values to 200, and then our dampening values to 2. All right, we'll do that for every single one of those. 200 for our stiffness, and 2 for our dampening values. Now, these are really the values you're going to want to play with. Now, under linear, we're going to checkbox all of these as well. And we're going to set our stiffness to 200. And our dampening, we'll set that to 1. I found that these values work really well. So 200 for the stiffness, and dampening will be 1. You can copy my exact settings that you see here on the right-hand panel. And let's go ahead and press play and just watch what happens. Make sure you give it a quick save. And we have a spring. Now, in order to really see what this spring is doing, we need to drop objects on it. So let's go ahead and add some objects. I'll add in a icosphere. I'll bring this up. And let's just go ahead and scale it down a little bit, move it off to the side so that it kind of falls off of our spring. And let's add our rigid body, type active. And then for the mass, I'll just make it 10 kilograms so that it hits the spring nice and hard with a lot of weight. Let's go ahead and save this and press play. And as you can see, it falls right off the spring. And what's really cool about this is we can just duplicate as many of these as we want to, and we can watch them all hit the spring. Pretty darn cool. And we have a spring just like that. Now, if you really wanted to, you could design a physical spring in 3D space, and you could use some parenting and some special techniques to actually make this look like it has a compressible spring to it. But that is really it for this constraint. Like I said, guys, in the actual constraints tab, you're going to want to mess with all these different settings. Right now we have our stiffness set linearly to 200. I'm going to show you what it would look like if we went ahead and set that to something like 50. Let's choose 50 for every value, and let's just go ahead and see the different result. As you can see, it's much more floaty in a way. It's not as much of a stiff spring. The lower that value is, the more that spring is going to move. So right here, it looks like it's almost completely loose, but it still maintains that spring-like quality. Now, if we went back and we raised this value to something extreme, like maybe 500 instead of 200, let's go ahead and set all these to 500. Let's press play. You can see that there's much more resistance, and it springs back much more quickly. So definitely experiment with those values. All right, guys, this is a really awesome constraint. Now, the next constraint that we're going to go over is the motor constraint.